Adding and subtracting decimals. To add and subtract decimals, we're going to line up the decimal points and then add or subtract as with whole numbers and bring down the decimal point. So let's look at an example. If you want to add 9.8 plus 2 and 12/100ths, so 9 and 8/10ths plus 2 and 12/100ths, we're going to rewrite them on top of each other but line up the decimal points. So it'll be 9.8 plus 2.12. Now, since the 2.12 has a digit in the hundredths, I'm going to add a 0 behind the 8 in the 9.8. It doesn't change the value of the number, it just puts a number in the hundredths place. It puts a digit there. So that 0 is there. So now we can just add as we would whole numbers. So 0 plus 2 is 2. 8 plus 1 is 9. Then you bring down the decimal. And then 9 plus 2 is 11. So 9.8 plus 2.12 equals 11.92. Now let's look at a subtraction problem. 8 minus 1.65. So we're going to use the same rule. We're going to write 8, and in a whole number the decimal occurs directly to the right of it. Because if you remember, you have the ones place, then a decimal, then tenths, hundredths. So any whole number, meaning like this one, an 8, the decimal would occur directly to the right. So we can write 8, and then underneath it we'll write 1.65. And then just like the last example, we're going to put zeros in so that we can do our subtraction. So 0 take away 5, we can't do that, so we need to borrow, but there's nothing to borrow from the tenths place. So we need to borrow from the ones, so that'll make 10/10ths, and then we need to borrow from that. So now we have a 9 and a 7. So 10 minus 5 is 5. 9 minus 6 is 3. Bring down the decimal, and 7 minus 1 is 6. So 8 minus 1.65 is going to equal 6.35. Okay, let's do another addition example. Let's say we have 8.75 plus 6.394. Okay, so let's rewrite it, but line up the decimals. So you have 8.75 plus 6.394. And just like the other two, we're going to put a 0 in the thousands place, just so that we have digits in both numbers in the thousands place so that we can add them. So 0 plus 4 is 4. 5 plus 9 is 14, so you bring down the 4 and you carry the 1. And then 1 plus 7 plus 3 is going to give you 11, so you have to carry the 1. And then 1 plus 8 plus 6 will give you, well, 1 plus 8 is 9, and then 9 plus 6 is 15. So 8.75 plus 6.394 will give you 15.144. Now let's look at an example where we use some algebra. If we have a problem that says evaluate 20 minus x when x equals 4.71, then we're really saying 20 minus x is the same thing as 20 minus, but instead of x, I'm going to write what x equals. And they're saying when x is 4.71, so 20 minus 4.71. So I'm substituting 4.71 in for x. Okay? And that's what algebra is. You have variables, and the variables are letters that just represent numbers. So it's saying that this letter x, in this case, is going to equal 4.71. So let's rewrite the subtraction problem, but line up the decimals. So you have 20, and remember, in a whole number, the decimal occurs directly to the right of the last digit. So 20 minus 4.71. And just like the other problems, we're going to put zeros in any of the places where we don't have digits. So 0 minus 1, we can't do that, so we need to start borrowing. So we have a 9, a 9, and a 1. Okay, so 10 minus 1 will give us 9. 9 minus 7 will give us 2. 9 minus 4 will give us 5. And then 1 minus, well, there's nothing here, so 1 minus 0 will give us 1. So the answer, when we evaluate 20 minus x, when x is 4.71, will be 15.29, and that'll be our answer. Okay, let's look at some properties of addition. We have the commutative property and we have the associative property. And what these say is that if you have two numbers, so 2 plus 5, with the commutative property, that tells you that 2 plus 5 is actually going to equal 5 plus 2. So what that's saying is you can add numbers in any order. It doesn't matter if you add 2 plus 5 or if you switch it around and add 5 plus 2. You're still going to get the same answer, which is 7. And that holds true with algebra too. If you use variables, you can write a plus b, or it's the same or just as valid to write b plus a. So it doesn't matter which order you add things in. And that's the commutative property of addition. Okay, now let's look at the associative property. What the associative property says is the value of a sum does not depend on how the numbers are grouped. So we can group things in different ways. So let me show you an example. If you have, and you know that grouping symbols could be parentheses, actually fraction bars can be used as grouping symbols too, but in this case we're going to use parentheses. So 2 plus 5 plus 4. So we're grouping the 2 and the 5. That's going to equal the same thing as 2 plus 5 plus 4. So we're grouping the 5 and a 4 there. So in this, the first one, we group the 2 and the 5, and the second one, we group the 5 and the 4. And the associative property says the value of a sum. So when it says value of a sum, that means when everything is addition. So we notice every operation in this example is plus. It's addition. So the value of a sum does not depend on how it's grouped. Does not depend on how it is grouped. And if you look at this, we know from order of operations that you do parentheses first. So if you want to evaluate this number, we first do what's in the parentheses. So the 2 plus 5, which is 7. And then we add the 4, which is 11. And then if you look at the other side of the equation, we're going to do the parentheses first. So the 5 plus 4 is 9. And then we add the 2, which is 11. So you still get 11 equals 11. So the associative property says that it doesn't matter how things are grouped. It's still going to hold true as long as every operation is a sum. And that's the associative property of addition. Now there's also the algebraic way to write this, and that would be A plus B in parentheses plus C. Here, let me start a new slide. A plus B plus C equals A plus B plus C. So that's the way to write it algebraically, and that's the associative property of addition.